Right, two forces F1 and F2 are given by as follows. F1 is 24I plus 32J minus 42K, okay, in terms of IJK unit vectors. And F2 that is minus 3I minus 72J minus 30K. So part A then says calculate, correct to the nearest degree, the angle between the directions of F1 and F2. Okay, so when it comes to working out the angle between vectors, okay, you think of that force there having a certain direction, F1 and then F2 having another direction, okay. We'd be interested in the angle between them. We use the formula which we've learnt, okay, from C4, right, and quite simply, there's a few ways this can be written. Cos theta equals to, in this case, because the two vectors are F1 and F2, you'd have F1 dot F2, okay, divide by the modulus of F1 times the modulus of F2, okay. So that is the general formula which you learn in C4, okay. And we'll work these out now carefully. The top here, F1 and F2, okay, you're dotting them, okay, the dot product. So F1 dot F2, okay, means you're going to multiply F1, which is 24I plus 32J minus 42K. Okay, you're going to dot that then, dot product it with F2. Okay, so when you do the dot product, you focus on the i's, you multiply the i's together. It's 24 times minus 3 is minus 72. The i's disappear then. Do the j's, 32 times minus 72, that was, wasn't it? I wrote it down wrong, but it's minus 72, so I need a calculator there. 32 times 72, 2,304. So it's a minus, isn't it? Because there's a minus there. And then multiply the k's together. 42 times 30. Let's just check that on the calculator. You get 1260. Okay, and then that's a plus 1260, isn't it? Because when we multiply the k's together here, you've got minus 42 times minus 30. Two minuses make a plus. So you've got that there for F1 dot F2. Okay. Just remember, when you do the dot product, when you multiply vectors together, you just simply focus on multiplying the i's together first, and the i's disappear, the j's together, j's disappear then, and the same with the k's. Let's put that together. Minus 72 minus 2304 plus 1260, and you get minus 1116. Okay, so that's F1, the product, dot product of F1 and F2. Now we're going to divide that then with the modulus of F1 and the modulus of F2, okay, the actual size of it, the magnitude of it. So we take the vector F1, okay, do the modulus of it, that would be then the square root, okay, of each of them squared. Okay, so you can do that with your calculator in one go. Of course, with the minus squaring, the minus would go anyway. You get 58. Okay, we'll do the same then with F2. Okay, so we're working out the size of the vector. When you work out the size, it's using Pythagoras, the idea of Pythagoras. So squaring them, adding them, square root it. So for F2, squaring each term, adding them. So when it comes to my calculator, I mean, I don't really need to put minus 3 squared in, because the minuses, as I said, disappear. So you get this here, 3 root 677. Okay, so now we've worked out the dot product of F1 and F2. When you do F1, the modulus of F1 and F2, then we'll just chuck all of that into the formula. So minus 1116 over 58 times 3 root 677. Okay, so you get whatever that is there. To get theta, then you just do the inverse cos to minus 1 of all of that. Okay, in degree mode. Okay, so I'll check it's in degree mode. And you get your answer 104 degrees. Okay, to the nearest degree it's 104 degrees. Okay, part B then. Okay, we move on to part A. Part B, it says calculate the mass, what does it say? A particle of mass 5 kilograms is moving under the action of F1 and F2. Determine the magnitude of the resultant force and deduce the magnitude of the acceleration. If you think about it, you've got this particle now, 5 kilograms, and there's these two forces acting on it, F1 and F2. Okay, so of course the resultant force will be them added together. Yeah. Okay, and don't forget, because they're vectors, I need to underline them. Okay, or you can see in the question that they're in bold. Okay, but underlining them sort of satisfies that then when we write them down. So the resultant force will be F1 plus F2. So you've got your F1 plus then your F2. Okay, so when I put all that together, the resultant force will be 21I, okay, minus 40, excuse me, minus 40J, minus 72K. Alright, so that's your resultant force. Now, go back to the question again, right? It says determine the magnitude of the resultant force. So we need to, remember now, if we've got that in vector form, we need to work out the magnitude of it like this. Okay, so we do the square root then of what we had there, so that would be 21 squared plus minus 40 squared plus minus 72 all squared. Okay, so I do that on my calculator. Get 85 out. Okay, 85 newtons. So the resultant force is 85 newtons. Let's go back to the question. So determine the magnitude of the resultant force, you've done that, and deduce the magnitude of the acceleration of the particle. So using Newton's second law, F equals ma, of course, and we know the resultant force is 85. We know the mass, it said, was 5 kilograms. Okay, so you can get your A then. So that means A then would be 17 meters per second squared, and you've worked out there the magnitude of the acceleration. We don't put that in there if you want. Okay, so you've got the actual magnitude of it, the size of it. We've answered the question.